Hello, everyone. Thank you for choosing to study this course in this semester. This course is about robotics. Since this is the first lecture of this course, then I will take this opportunity to give you a quick introduction. I will follow this outline. First of all, I will give you a short introduction about myself. Then I will give you a brief overview about the robotics. Lastly, I will give you some instruction and the guideline about learning. Let's start with the short introduction about myself. My name is Xianmin, and you can find my detailed background from this homepage. And in terms of education, you will see that I did my first degree in control engineering in China. Subsequently, I did my master and the PhD degree in France. Both master and the PhD degree are in the area of computer science. In terms of research achievement, here I just show you this result. In year 2003, I have published this monograph on robotics. In year 2021, I have published this monograph on artificial intelligence. And here you see this picture. This picture shows you the first adult-sized humanoid robot in Singapore, which has been developed by us around the year 2008. In year 2004, we have launched this International Journal of Humanoid Robotics. I am one of these three editor-in-chief. For my teaching portfolio, you can find the detail from this web page. In terms of research, my focus covers basic research, applied research, and product innovation. The two keywords related to my basic research are intelligence and motion. Therefore, there are four pillars inside my basic research. The first one is cognitive vision. The second one is cognitive speech. The third one is intelligent design. And the fourth one is intelligent control. And around these four pillars of basic research, I'm also doing applied research. And in terms of product innovation, my interest is mainly on industrial robot, medical robot, special robot, and service robot. Here, I would like to show you some video about the motion machine with intelligence inside. And this video is for comparison purpose. This video was from NASA, which show you the future trend of human-robot interaction at the cognitive level. And this video show you what we have done in year 2008 under the framework of human-robot interaction at the cognitive level. This video shows you the scenario of human-robot interaction at the signal level. Signal means the sensory data from different type of sensor, such as force sensor, torque sensor, etc. Okay. This video shows you the achievement of level 1 intelligence by robot. So this is a typical scenario or most popular scenario of autonomous behavior. And in this case, we call it as hand-eye coordination. So you will see 12 years ago, robot has already reached level 1 of intelligence. Now I'm going to play these 4 videos for you.
Now what I want you to do is look at me, look up at me. I want you to move that way. Get a little bit of a bend in the rod. Now look back at the rod. Try and look back at this rod right here. Try and get that straight so it's not down. And then come towards me a little bit, a little bit, stop. Okay. Now put a bend in. Put a bend in like that. Good. Good. Now go back to straight. Make it straight. Very good. Now put a bend in it the other way. Okay. Now straighten it out again. Okay. Now I want you to go down. Lower your arm. More. Okay. Stop right there. And now I want to back out. Move this out. Okay. Release. I close my hand. My arms ready. Yeah. I had to go to my desk.
Our research work has been widely publicized in Singapore. For example, this photo was taken by NTU and was published in national newspaper. And the video has been shown in the national media platform. All right, so that's about myself. Now let's move on to the brief overview about the robotics. We know that we are the greatest creature of nature, or for those of you with religious belief, then you may say that we are the greatest creature of God. All right, and this slide basically shows you the tree of life. You will see we belong to the same family. So it means all forms of the life on earth belong to a same family. Okay, and here you can see where we are. So we are here. Okay, so then okay, together with other form of life. Okay, so you see our family is very big. All right, then you may ask this question: what should be the greatest creature of a human being? The answer will be robot. Here I show you 2 forms of a robot. One is in the form of a human being, so you will see human-like robot. And the second one is in the form of animal. You will see we have a dog-like robot. All right. Therefore, we need to know what should be the definition for today's robot. And this slide shows you 3 key components which should be included inside the definition of today's robot. The first component is about the ability to execute programmable or reprogrammable motion. The second component is about the ability to perform programmable or reprogrammable tasks. And most importantly, the third ability or third component is the ability to interact with human being at the cognitive level, because interaction at the signal level is easily achievable. But for interaction at the cognitive level, that will be a challenge. Okay, today it is still a challenge for us to make a breakthrough. Okay, and this slide show you why there is still a challenge for us to achieve human-robot interaction at the cognitive level. For example, if we want to achieve or realize this scenario of human-robot interaction with the use of human language, okay, or spoken language, you will see at the human side, we must invoke this capability or this mental capability. The first one is to convert speech to text. Second one is to convert text to meaning. And the third one is to store understood meaning and to generate or reproduce intended meaning and convert intended meaning written in the form of a language into speech. And then we speak out the meaning through the voice, all right? Then at the robot side, a robot must have a similar mental capability. The first one is to convert speech to text. Second one is to convert text to meaning. And the third one is to store understood meaning and also to self-generate intended meaning and convert intended meaning written in the form of human language to speech. Then robot must speak out the meaning in the form of a voice. Okay, today robot could perform this mental activity, that is to convert speech to text. However, for the second mental capability, it is still a challenge for us to make a breakthrough. Okay, and for those of you, if you would like to continue the journey of your study all the way to reach PhD degree, this could be the area for you to choose to work on in order to make impactful breakthrough or achievement. All right. Okay, now we look at the history of a robot, because in the previous slide, we understand, okay, what is a robot. Then we would like to know, okay, whether the history of a robot or robotics is a long or is a short. And this slide basically tell you that the robot or robotics has a long history, okay? It's not the short history. So this is robotics is not the new business. Actually, robotics is the old business of a human being, okay? This photo was taken from a museum in China. And then you see 500 years BC, our ancestors have had the intention to create human-like creature. Okay, this is the evidence which shows the early years of robotics history or robot history. All right. Then subsequently, our ancestor has invented this scheme of making robots motion to be programmable and reprogrammable. But of course, In this scheme, you will see we use a human's brain to control the motion of a robot. All right, but surprisingly, this scheme of programming robots motion has enabled us to design medical robot. Later on, we will show you a video. Then you will see in terms of working principle, they follow exactly the same scheme or same principle. All right. So it's very interesting for you to see that this working principle, this is a very old working principle, still play a very important role in today's robotics industry. All right. And actually, the acceleration for the development of a robot occurs in the last century because of these three important events. The first event is the birth of the name robot, which occurs in year 1921. The second event was the birth of a robotic term, which occurred in 1941. The third event was the birth of industrial robot, which occurred around the year 1949, because in year 1949, there is a demonstration of a teleoperated robot. So actually, teleoperated robot is a kind of implementation of this scenario, because if we use today's term, this is a typical scenario of a teleoperated robot. John, you can see that this is the first generation of a teleoperated robot. Then we have a second generation of a teleoperated robot. All right, and after that, then another important event was the formation of the first robotics company in the world, in USA. All right, so this slide basically highlight to you the important event in the modern history of a robot or robotics. Okay, and it is important also for you to know the three rules for us to follow in order to design, develop, and deploy robot in industry and in society. All right, and these three rules were formulated in year 1942. All right, and in parallel in Asia, especially in Japan, you will see the modern history of a robot and robotics are quite similar to the modern history of a robot or robotics in Western country. And you will see the investment in Japan was studied with the development of pupper. Okay, so we developed the first generation of the pupper all the way toward the second generation, and eventually to develop autonomous robot or third generation or fourth generation. All right, and in particular, I would like to highlight, okay, the achievement made by a single company in Japan. Okay, so you will see Honda is an automobile company. However, it has heavily invested in the development of a robot, in particular, the development of a humanoid robot. So you will see the development of a robot in Honda was started in year 1986, and all the way until today. Also, here I just show you the result achieved by Honda in year 2005, because at that time you will see the result is very, very remarkable already. And this company continue the investment, continue the development of humanoid robot until today. Okay, and here I will show you some video which give you an idea about the state of the art of humanoid robot development made by Honda.
To this day, this engineers have continued to improve.
All right. So by now, you know the answer to the second question. Okay, what is a robot? And now we move on to answer the third question. What can be done with the robot? So actually, robot can contribute significantly to the growth of our economy, and in particular, to the growth of industry output. And this slide basically show you the trend of deployment of a robot in industry. You will see this trend is growing, and this trend will be further accelerated by Industrial 4.0 or by the new trend of achieving robot integrated manufacturing. So therefore, you understand that a lot of things could be done by robot. All right. Now I'm going to show you some scenario in which robot could help us to undertake industrial tasks and help us in medical field and help us in providing service in home environment, etc., and eventually for transportation, etc. All right. And this video will show you the typical application of pick and play. Okay, so you can consider this as material handling, or consider this is for assembly operation, etc. This video will show you the typical scenario of material handling with coordination among the 3 robotic arms, which involve the execution of a complex motion dynamically. This video shows you the typical example of making use of a robot to do dirty job, because to pan the surface, this is a dirty environment because of a particle of a pan which flow inside the air. All right. This video shows you the situation of handling heavy object in industry or in production line. Therefore, we can make use of a robotic arm to do this heavy task. So this type of a task, we call them as a difficult job, because for human being, if we want to ask a human worker to repeatedly to do such task for 4 hours or 8 hours, it will be very, very tiring for human worker. And here is another typical example of making use of a robot to do difficult job. And in this case, you will see this giant robotic arm carry a heavy object. Therefore, you can imagine it is impossible for us to hire a human worker to do the same job. All right. This video show you a typical example of making use of a robotic arm to do dangerous job, because welding is a dangerous job, because this kinds of a working environment is harmful to the physical body of a human worker. Therefore, we can make use of a robot to free human being from working in this type of environment. Okay, this video show you our achievement with industrial project. So this is the result of our industrial project done in China. And the project is to fully automate this sintering process in manufacturing. Sintering process will take powder as an input, then produce the solid as an output, and the solid object will take up the shape of inner cavity of the die. The die has an upper die, lower die put together. Then inside we have a geometry of the cavity. So the output solid will take up the geometry of the cavity of the die. All right. And in this example, we have a design and implement a dual arm robotic system.
对取粉
So you see the input powder of specific material. Then we close the die. Okay, in this case, we have a 2 cavity inside the die. So therefore, we need to supply the powder to both of them. Now we close up the die. So you have an upper die, lower die. Then we heat up the powder, then cool down the powder. Therefore, then the output will become solid. All right. Here we have an additional process, which is to create a colorful surface on top of the solid. So therefore, we print the colorful painting on the special paper. Then this paper with a colorful pen could be incorporated into the surface of the output solid. So you see, it takes time to heat up. It takes time to cool the final solid. All right. Now the process has been complete. Then we take out the solid as the output from this station. And this output will be the input to another station for the polishing of the edges. All right. This video shows you the typical scenario of robot integrated manufacturing. I believe this will be the future trend in manufacturing, and this may be the scenario of Industry 5.0. Today, we may heard of Industry 4.0. Then people may ask this question: what will be the scenario of Industry 5.0? I believe this video shows you the answer. So you will see there is almost no human worker in the production line. All right. Okay, previous video show you the typical application in manufacturing. And this video will show you the most advanced application in medical domain. And this video also show you today's scenario of tele-operated robot. And you can consider this one as a second generation of pupper. You see the pupper of the first generation, and we have a human being directly control the movement of the pupper. Okay, and in this case, if you just treat pupper as a robot, today's robot, then the doctor will control the movement, the motion of pupper. Okay, so you can imagine this is a second generation of pupper. Okay. So you will see a doctor will use this very sophisticated workstation to control a remote robot. So this is a remote robot with 4 arms. Okay, the arm will enter inside the body of a patient. Then the movement of the arm will be fully under the control or instruction by the doctor. So therefore, this is a modern version of pupper. Okay. So you will see the doctor use the haptic device, okay, to output motion, and then the robot, remote robot, just follow the intended motion instructed by the doctor. So you will see doctor will output his or her intended motion, then remote the robot, or you can call them a pupper in the older term, okay? Just perform the intended motion instructed by the doctor, all right? And here you will see the setup of 4 robotic arms and the penetration of these 4 robotic arms into the patient's body. Among these 4 arms, one of them will serve as an eye, another of them will serve as a lighting, or 2 of them will serve as a 2 eye, and another pair will serve as a dual arm. Okay, and here you see the real picture, okay, taken from inside of a patient's body. So you can just imagine, okay, so we have two eyes from the doctor extended, okay, inside the body. We also have a two arm, okay, extended into the patient's body. So this is why you see we have a four arm, okay, which penetrate inside the patient's body. All right. This video shows you the future scenario of a deployed service robot into every household, every home, okay? And it is possible for such a service robot to become a standard item in every home, because today in every home, we have a refrigerator, we have a TV, we have an air conditioner, etc. And maybe in future, service robot will also become a standard item for every home to have. All right. Okay, so we move on. And this video is very interesting. This is a project result that we have done in NTU in year 2000, almost 20 years ago. And this video will convince you about the future trend of making vehicle or car to become a high-speed mobile robot. Therefore, future automobile industry will become a part of a robotics industry. And this will give you a strong motivation for you to spend time and effort in order to study well robotic course. because robotics has a huge industry in future. All right. This video shows you a typical scenario of a car following. This mobile platform follow the frontal moving target, and this moving target could be another vehicle. The behavior from this mobile platform or car-like mobile platform is fully autonomous. Okay. By now, I hope that this application will be convincing enough for you to design. Okay, and whether you would like to spend time and the effort to study well this course or not. All right. For those of you, if you are excited about the study of robotics course, then you may want to know, okay, what will be the learning objective, what will be the content for you to study, what will be the methodology for you to follow, and how will this course being conducted, and how will be the learning outcome being assessed, etc. All right. So in terms of methodology of teaching and the learning, this course will include video-based self-learning, classroom-based interactive learning, and also experiment-based live learning. Okay, because we have recorded lecture video, and we have also scheduled classroom study. Okay, and the class will be divided into smaller group, and each group will be given a robot construction set, so that each group will work out its own robot design and the implementation and the demonstration, and the result from the project will be graded. Okay, so this course will include these three modes of learning. In terms of objective of learning or teaching, we have two objectives. The primary objective is for you to become a designer of the robot. And the secondary objective is for you to become a user of the robot. So therefore, you must adjust your mindset and put yourself into the mindset of a designer. In this way, you will be able to link all the topics together, okay? And make your study more enjoyable, all right? And with the keyword designer in mind, and in the right-hand side, I give you this flow of thinking as a designer of any product, okay? So the first question a designer may ask will be, who are the user? The second question will be, what are the need or demand from the user, okay? So therefore, by following this flow of thinking, you should be able to come out the detail, which will lead to the prototyping and the testing, optimization, and eventually mass production, and all the way go to the marketing and the sales, etc. Okay, but for this course, I would like you to focus on the solution or on the answer to these four questions. Question number one, who are the user? Question number two, what are the needs of the user? Question number three, what are your robot which could meet the need of your user or buyer? Question number four, what are the solutions behind the design of your robot? All right. For the answer to the first two questions, you are totally free to provide your own answer, because in future, okay, different students will work in different industry. So it is difficult for us to have a common answer to the first two questions, okay? However, okay, for question three and the question four, this course will provide you the knowledge and the principle in order to drive out the detailed answer, okay? So from here, you will see then the learning objective of this course is for you to learn the knowledge and the principle, which will enable you to derive your answer to question number three and the question number four, okay? For example, this slide shows you the generic answer to question number three, okay? What will be your robot, okay? What are your robot which could meet the need of your user or buyer? So basically, you need to know what will be the blueprint of your robot, okay? So this slide gives you the general guideline for you to drive out the blueprint of your robot. Or you can treat this as a functional diagram, because in product design, we must come out a functional diagram, okay? So this is a generic functional diagram of your robot, okay? And if let's say today you cannot understand the meaning of each module inside this blueprint, it is okay, because when you reach the end of the study of this course, then you will be able to fully understand, okay, each module inside this blueprint, okay? The next question will be, what should be the knowledge and the principle for you to learn in order for you to understand the full detail of every module inside this blueprint? The answer will be this slide, okay? So this slide basically show you the topics that you are going to study within this course. With the knowledge about all these topics, you should be able to come out this functional diagram of your robot, all right? And I structure all these topics into 4 modules. Module number 1 is about the robot mind, which will include these topics. such as task planning, action planning, motion planning, path planning, trajectory planning. Module number 2 is about the robot body, which will include these topics such as robot system, robot brain, robot mechanism, robot actuator, robot sensor. And module number 3 is about the robot modeling, which will include these topics such as robot kinematics, robot dynamics, robot statics. And the 4th module is robot control, which will include these topics such as robot motion system, dynamics under control, control diagram, joint space control, task space control. All right, I will teach you module 1, module 2, module 4, and the thought-provoking one will teach you module 3. And in total, we are going to spend 39 hours to study this course. 18 hours will be dedicated to the study of module 1, module 2, and the module 4. And the 21 hours will be dedicated to the study of module 3. Why do you need to spend so much time to study module 3? The reason is because module 3 involves a lot of mathematics for kinematics, for dynamics, and for statics. So besides lecture video and lecture slide and project, and you may also refer to the textbook or reference book in order to complement the study of this course. You can borrow the textbook and reference book from university's library. All right. And the last question you may have in mind is about the way for us to assess your learning outcome. For this course, the final grade will have 2 components. One is CA, the other is final exam. CA will count for 60% of the final mark, and the final exam will count for 40% of the final mark. CA will consist of 3 quizzes, 1 project, and 1 assignment. And the final exam is an open book exam, which will last for 2 hours. All right. So that gives you an overview about this course and a short introduction to robotics. So I hope that you will stay on to study this course. And I wish to see you in lecture 1 of module 1. All right, thank you for your attention.